Hello and welcome to another Evony video with Summer. In this video, I'm going to talk about the Tavern again. So in the last video, I talked about the probability of getting certain generals and how that changes if you upgrade your Tavern. In this one, I'm going to talk about the theory that the chances of getting certain generals depends on what day of the week you look at the Tavern. So there is this table going around saying that certain generals are available in certain days. And what people usually say about it is that they are more available in certain days, maybe meaning that the chances of getting them are higher, but it's not zero on other days. And it is based on observations that different players have made. And the bottom line is that I don't think that is the case. I'm going to explain that to you. And it's up to you to see which you find more convincing. So let's take a look at one certain general. Let's take Margaret the First. You can see here the probabilities that the game gives us for her is this 0.13%. So these chances don't change in different days. I have been looking at these for a couple of weeks now, every day, and they're the same. I know you are probably thinking, why do you trust Evony? How do you know they actually use these numbers? That's true, I don't really know. But then that's the first thing to consider, right? If these were changing, there was a definite answer that it depends on different days. But now let's see how and when can we say, based on our own observations, that these values are different in different days. So let's take Margaret the First. Let's say we do 100 refreshes each time we try, and I'm simulating the outcome that you would get based on the probabilities that I calculated in the previous video. If you haven't watched, you can look at that. The final chance of getting one Margaret the First in each refresh is equal to this value. So if I simulate this 1000 times, on average, I get this. So it's almost never getting any. And this is also the theoretical range for it. So 1000 simulation runs is enough for you to actually get close to the theoretical range. So then from the 5th percentile to 95th percentile of doing this over and over, it's almost always zero. So you rarely get one. It's almost always none, right? So if you do this in different days, each day you do 100. Some days you might get one, but that doesn't really tell you much. So now let's say we do many more. So each day you do 500 refreshes. So this is what it looks like. So again, the average is now 0.2. So let's say every 5 days of doing this, you're gonna get one copy. And the maximum is generally one. In very rare cases, you might actually get 2 out of those 500 times. So you might say, oh, I did this on one Tuesday and I got 3. How do you explain that? We're gonna get to that soon. So here, I'm calculating certain things to see with what observations can we make conclusions about these probabilities being different. So as I mentioned in the previous video, this becomes a negative binomial distribution, and this type of distribution has a very long tail, which means that the range of number of tries you need to make until you get to a certain number of copies for a general can vary differently with the exact same probability. So here, let's say we want to observe a difference. So let's say this chance, instead of being this 0.04, is this much higher. So it's basically 50% higher than what it actually is stated here. So 50% higher or lower, right? So, okay, in one day, we say it's a bit more likely for it to happen. Instead of 0.04, it's 0.05 or 6. Then you're doing that in 2 days. So it doesn't have to be like 2 days. You can, let's say you do it many times on different Mondays. You do it many times on different Tuesdays, and you want to see if that is there's a difference. And if you want this to have a significance of 5%, significance means that if there's no real difference, you'll falsely find one with that probability. So there's only 5% chance of you basically finding a difference that is not really there. So if you really want to be confident that the difference you saw is not false, and if there is an actual difference, you will see it with 80% chance, then you would need to refresh 200,000 times per scenario, basically per day, right? So you need to refresh. Let's say we're saying on Mondays is more likely to happen. So on different Mondays, you need to do in total 200,000 refreshes and record that number, and do 200,000 refreshes on other days of the week and record that number. Then that can enable you to see if there is a difference or not. And until now, I'm not getting into how different those number of copies that you got in 200,000 refreshes are. It's just telling me, for me to be this confident, based on how the distribution is going to look like, I need to do this many refreshes in each scenario. Okay, so now let's say we are refreshing just the same number of times each day. So if it is 500 times, and let's say in one day I get 0, as it's most likely to happen, and in one day I get 2, there is a 50% chance that this is just purely luck. Right? So although you see that the chance of 2 happening is very low, but because the number of observations I have made personally, those 500 refreshes in each scenario is not really enough for you to conclude if this is just your chance or is it the probability behind this that is different. So, and if you want to detect a real difference, again with a significance of 5%, you actually don't have enough refreshes now to say anything about it. That's why you see this. We need at least 7,000 refreshes per day. So now let me change this to 7,500. Okay, so around 3 each try. So here, if you want to be really confident that the difference you are flagging, you are 95% confident that that's a real difference, then the difference you see in these two tries, so 7,500 on Mondays and 7,500 on other days, the number of copies you get, the difference between them should be at least 6. And take a look here. The 90% confidence interval is between 0 and 6. So it means in one scenario, you should get nothing out of those 7,500 refreshes. And in the other one, you should get the maximum theoretically possible. It's not the real maximum, but it's the 95th percentile. You get the idea. So if that happens, then you can be really confident that, okay, the chances behind this are different. So let me go out on a limb here and say it's probably not the number of observations people have made to make that table. So, but I understand, I think the reason that this theory is getting traction is it gives you a sense of control, because this is such a boring task to just keep refreshing and refreshing, and it's just you have no control over it, so you just have to do it as many times. Oh, I got her, but I have enough of her. But you need to keep doing this so many times with zero control. But this idea of, okay, if I do it in certain days, I will get what I want, gives you some sense of control, so it makes it less boring. And also then a confirmation bias comes into play, because, well, when you see that table, you're not gonna look for a general that is not on there. Let's say I'm trying on Mondays. I'm not gonna look for a general that is supposedly not really available on Mondays and spend a lot of gems refreshing the tavern to see if I find that or not. Doesn't really make sense, to spend gems and time to just verify if this theory is correct. And also, there's the other bias of what you remember, right? You don't really remember how many times you clicked. You just remember, oh, okay, it was a Monday, I got a good outcome. You don't really compare them that accurately. But anyways, it's fine to still believe in that. The reason I did this video was just to not, uh, you know, take it so hard on yourself to see, oh, I need to be careful with which day I look at this. Just do it whenever you have time to kill, and you can just click refresh or whatever. That should be good enough. And all you need to do is to invest time and energy on this to get the journals that you want from it. So I hope that this was convincing enough. But if it wasn't, still not a big deal. Thank you, and until another video, bye.